today we're going to have a look at a couple of questions on hidden quadratics. So the first one we've got here is where we're solving a quartic equation, and this might look quite intimidating at the start, but we can actually rewrite this to make it look a little bit nicer and allow us to use a method that we're used to using for solving quadratics. So the first thing I'm going to do is I'm actually going to rewrite this equation. So instead of writing x to the power of 4, I'm going to write this as x squared squared. What I can now see is that I've got an equation in terms of x squared. And you can possibly already see the quadratic kind of forming in what we've got looking at us. So I can kind of see that I've got a squared term, I've got a numerical term. It does look like that quadratic we're used to seeing. So in order to make this look like a quadratic that we're used to, I'm going to use a substitution. Now you can choose any letter you like. I'm going to choose y, so I'm going to replace all of the x squareds in my equation with the letter y. So this is going to give me y squared minus 13y plus 36 is equal to 0. So here we go, here's our quadratic. This is what we're used to seeing. Now there's various different methods of solving a quadratic, and you might have one that you like to use. You could factorise, you could use the quadratic formula, or you could even complete the square. I'm going to factorise this one because it's a nice easy one to factorise. There's some nice factors in 36. So I can see that the factors of 36 that add to make negative 13 are minus 9 and minus 4. So I can solve this in my usual way. So y is going to be equal to positive 9, or y is going to be equal to 4. Now I haven't finished yet. This is not the answer because we are trying to solve an equation in terms of x. So this means that our final answer does need to be in terms of x. So what I'm going to do is I'm going to come back to my original substitution and bring myself back in terms of x. So instead of having y equals 9, I can actually write this as x squared equals 9 or x squared equals 4. So lastly, just to get x equals, I'm going to square root these. So I can have a plus or minus 3 or a plus or minus 2. And these are going to be my final answers. Now remember that you can check your answers by substituting them back into the original and making sure that they do indeed give you what you expected. So for example, if we were to choose x equals 3, we could substitute this back into the equation and just make sure that yes, it does equal 0. And we're happy that that is the solution. So do check your answers at the end. It's a really good strategy for your exams. Okay, this one does look a little bit nastier. So we've got square roots. It's perhaps not quite so obvious where to start. It doesn't quite look like that quadratic. It's not as easy to spot, but we can actually manipulate this so it does look a little bit nicer and perhaps makes it a bit more obvious what we need to do. So my first step is I'm going to clear the fraction that I've got in here. So I'm going to multiply all of the terms by root x. So when I multiply the first term by root x times root x is just x. So I'm going to be left with 3x. My second term, when I multiply by root x, I'm just going to be left with 5. And my third term, I'm going to get 16 root x. Now it's helpful at this point to rearrange it in the form a function equals 0, because that's what our quadratics are used to looking like. So what I'm going to do is I'm just going to subtract the 16 root x so that it's in that equals 0 form already, what I need. Okay, so again, you might be thinking to yourself, oh, this doesn't look like I'm going to be able to find an easy substitution. However, because root x multiplied by root x is x, I could actually write that x term as the square root of x squared. And now it might become a little bit more obvious. Okay, I can actually use y equals root x as my substitution. So you're probably starting to think, oh, I can see that quadratic now. It does look like that quadratic, and when I replace my y, there we go, there's my lovely quadratic that I'm going to solve. Now again, you can use whatever strategy you'd like to solve this quadratic. Once again, I'm going to use factorising. This will factorise into two brackets quite nicely. But if you're worried about factorising, especially factorising quadratics with perhaps coefficients of y squared greater than 1, you might find using the quadratic formula is slightly quicker. So this factorised solution leads to y equals 1/3 and y equals 5. So lastly, I've got to come back to my x. I'm solving a function of x. I need to end with an x. So I'm going to have root x is equal to 1/3 and root x is equal to 5. And then to finish off, to get my x equals, I'm going to square both of these to get x is 1/9 and x is 25. And once again, I could substitute these into my equation just to check that they are indeed the correct solution.